hopefully that you are doing well. In this video, inshallah, we will solve some questions. They were mentioned in the revision sheet. So let's say Bismillah and start. Question number 1, it says calculate. Just we need to find the product. We need to multiply. So I'm going to solve this with you. First, you have 201 multiplied by 13. So what is the first step I need to do? Actually, the first step is to multiply the ones digit of this number, the second number, by the ones digit of the number above. And then the same digit by the tens place. And then by the hundreds place, okay? Or hundred place. So let's multiply directly. As you see, 3 times 1 is going to be 3. 3 times 0, it is what? It is 0. And 3 times 2, it is what? It is 6. Great. And now the other step is to know that we need to start in another step. So we will prepare for it, but we don't forget that we need to put the 0 down, and we say 0 is the hero. Do you remember? And now it's time to erase anything else, and if we have any regrouping, we should erase it and start directly in what? In multiplying the tens place of the second number by the ones, tens, and hundreds places of the number above. So let's start. Again, here we go again. 1 times 1 is going to be what? It's going to be 1. Good. 1 times 0, it is 0. Great. And 1 times 2, it's going to be 2. Great. And now what should I do, teacher? I should add. So let's add them with each other. 3 plus 0, it's going to be 3. 0 plus 1 is going to be 1. 6 plus 0 is going to be 6. And finally, 2 and nothing added to 2. So it's going to be what? It's going to be 2. Teacher, what do you mean? It means that there is a hidden 0 here. We said. So 0 plus 2 is going to be 2. As you see, so the final answer or the product is 2,613. Don't forget to add ones to ones, tens to tens, hundreds to hundreds, and also thousands to thousands. So now with you, I will move to division questions actually. Long division questions. Inshallah, I'm going to start with question number 7. So let's remember the steps of division. Remember, what do we make? The first step ever, we divide. We used a way to memorize the steps. We said dad, divide, mom, multiply, sister, subtract, and brother, bring down. So divide, multiply, subtract, and break down. These are our favorite steps. So, and I did not forget to bring the divisor times tables. So, look what did I make? I brought all of the times tables related to 35, or including 35 as a factor. So as you see here, look here, I got 35 times 0, which is 0, 35 times 1, which is 35, 35 times 2, which is 70, which is, 35 plus 35, which is 70, and also 35 times the 3, it's going to be 105, which is the previous answer, or the previous product of the 35 times the previous number. You will add 35 to it, so you're going to have the next factor, the next product, inshallah, as you see. So here we have 57, or sorry, let's say, can we say 5 divided by 35? Since the first step is division, so can we say 5 divided by 35? Or how many 35 in 5? Of course not. So we take the other digit with it. So we have 57. Can we say how many 35 in 57? Yes, of course, because 57 is bigger than 35. And let's start. We ask ourselves, 35 times what? We get 57. Or if it's not exactly, we can say, what is the closest number to 57, and it is less than 57. We get it when we multiply 35 by it. So it's going to be number 1 actually. Why? Because 57 is going to be here between 35 and 70, and you can say, oh yeah, because 1 is the number I multiply by this divisor, which is 35, I get a number less than 57. So 57 is here. We say it. So yes, it's going to be 1. Or you can say how many 35 and 57 is going to be, yes, it's going to be 1, only 1. So we put 1. Now we divided, the next step is going to be multiplication. So 35 times 1, this is the time of multiplication step. So, Joe, okay. 1 times 35, guys, it's going to be 35. Good job. And now the next step, we say it as S. We should subtract. So 7 minus 5, we start with the ones in place in our subtraction, right? 7 minus 5 is going to be 2, and 5 minus 3 is going to be 2 also. Okay, now we got a number, which is 22. Now, we don't forget to bring down BB. We should bring down. What is that? It's going to be the digit that we did not use, okay? Which is here in 5,765. It's going to be 10th place. So let's bring it down. So we have 226. Now we ask ourselves, how many 35 in 226? Or 35 times what? I get either 226 or a number close to it and less than it. Let's check. We have 35 by a number. We get 140, which is number 4. We have 170 by multiplying 35 by 5. We have 210. By multiplying 35 by 6, and we have 245. Oh no, it's bigger than 226, so we don't want it, okay? So, oh yes, we got 210 because it is less than 226, because 226, it comes here between 210 and 245. So, as you see, guys, it's going to be here. So, what is the factor? I need to multiply by 35 to get this 210. It's going to be 6. So, yay. 6 here. So we divided. And now what should we do? We multiply this digit that we put recently by 35. 6 times 5 is going to be 0. And the 3 will be regrouped here or carried out. 6 times the 3, 18. Plus the 3, it's going to be 21. Amazing job. And now it's time to subtract. Excellent. 6 minus 0, it's going to be 6. 2 minus 1, it's 1. And 2 minus 2, of course, it is 0. And now after subtraction, we have to bring down 5. Let's bring the 5 down, which is the last digit which was not used before. So we have 165. So here we go again. We go to that 35 times tables again to see which number I multiply by 35. Either I get 165 exactly, or I get a number close to 165 and less than it. So 165 actually it comes between 140 and 175. But we take the factor that we multiply it. We multiply it by 35, we get a number less than 165, which is number 4. Good job. So we put 4, so we divide it after division, we multiply 4 times 35. 4 times 5, it's going to be 0, and 2 will be carried up. 4 times 3, it's 12, plus 2, it's going to be 14, yay. So, and after this, we have to subtract. 5 minus 0 is 5, 6 minus 4 is 2, and 1 minus 1 is 0. Okay, you get a number. I need to check, is there any left digits? I need to bring down, actually, no. Now, what do you think about this number? Is it greater or less or equal to the divisor? Actually, it is less. So that means this number is called a remainder. So your remainder is going to be 25, and your quotient is 164. And don't forget, if you want to check your answers, guys, just you in long division equations, just you multiply the quotient by the divisor, and then you add the remainder. Of course, you have to get that dividend, which is 5,765. And that's it. If you have any question related to dividend, just don't hesitate to ask your teacher. And I want just to solve some questions about divisibility with you. Remember, divisibility by 3, it means when you add the digits to each other of the number that we are testing its divisibility by 3, we need to add the digits to each other. If the sum is divisible by 3, so yes, it is divisible by 3. Teacher, what do you mean by divisible by 3? I mean, if the sum of the digits, when you added them up to each other, if it is one of the 3 multiples, like 3, like 3, like 6, like 9, like 12, which are the products of which are the answers of 3 times table. So yeah, or the products of 3 as a factor. So yes. So in this way, if the sum is one of these numbers, 3 multiples, I mean, so of course it's going to be divisible by 3. But what about 6? It has to be divisible by 3, as I said. So all of the digits sum supposed to be divisible by 3. I mean, one of 3 multiples, and also there's another condition. It's supposed to be even number. Yeah, makes sense, because 6 is one of 2 multiples. So yes, and 2. When the number is divisible by 2, it's supposed to be even. So it makes sense that 6 is one of 2 multiples. So yeah, it is supposed to be even. Okay, and 9. What about 9? Just also you need to add all of the digits to each other. If the sum is divisible by 9, I mean one of 9 multiples, so yes, it is going to be what? Divisible by 9. And there's a very important note. There's a very, very important note. Any number is divisible by 6 or divisible by 9, of course, by default, it is divisible by 3. It is a condition because 6 and 9 are multiples of a 3, right? But the converse is not, it doesn't need to be correct. I mean, if it is divisible by 3, it doesn't have to be divisible by 6 or divisible by 9. Like number, let's say 3. Number 3 is divisible by 3, but not divisible by 6 and not divisible by 9. And another number, let's say 21. Yes, it is divisible by 3, but not divisible by 6 and not divisible by 9. Got it, guys? So here, in testing the divisibility, or working on divisibility tests and determining which number is divisible by 3 or 6 or 9, I want to say a note about divisibility by 6. There's a specific kind of number you need to exclude directly without spending much time on them. What do you think they are? They're going to be the odd numbers, because we said one of the conditions that you need to follow about testing 6 divisibility is what? As a checking if the number is even. So of course you need to exclude all of the odd numbers, like 2,907, 6,567, and so on. For example, this number I'm going to exclude it because they are odd numbers. So it's a very important note. It will save your time, inshallah. Here, just you need to match each 3D shapes, each 3D shape to its correct net. So easy. Just you need to imagine and to count actually the faces and the sides. So here 1, 2, 3 for the cube, and 4 down, and in this side we have 5, and back we have 6. So 6 square faces you have. So of course the net is gonna have 6 square faces, as you see here. So used this way, it makes sense to be used. And what about this? It's a pyramid. It's a square base pyramid, as you see. So you need to have how many faces? 1, 2, 3, 4 for our triangles, and 1 is what? 1 is a square. So I have to have 5 faces. 1 is a square, and the rest they are a triangle. So of course it's gonna be the correct answer. And what do we have also? I want to proceed with this question. Write the digit in each box so that the numbers are divisible by 9 first. So guys, I want your help to just fill the boxes with one digit number such that the total number, I mean the whole number, is going to be divisible by 9. So what should we do? Just we check and we should master the divisibility rules, okay? And the conditions of them. So divisible by 9, it means the sum of the digits is supposed to be one of 9 multiples. So 3 and 8 and this number added to each other is supposed to be one of 9 multiples. So let's say 3 plus 9 first is going to be what? It's going to be 11. Let's choose a number. We add it to 11, we get one of 9 multiples. What about let's say 7? Yes, let's check. What about 7? We said 11 plus 7 is going to be 18. Yes, and 18 is one of 9 multiples. So this number completely and the whole number is divisible by 9. It means when you divide this number by 9, you will have 0 as a remainder. What about this number? 540 something. So what is this something? What do you think? 4 plus 5 is 5 plus 4 is 9. What about 0? So 9 plus 0 is 9, and 9 is divisible by itself. I mean, it's one of its multiples, right? Okay, I will leave this for you, but to me, I'm gonna put 6. Do you have any other suggestion? It's okay, we can have different answers. What about divisible by 6? Divisible by 6, all of the numbers supposed to be even. I mean, the first digit is supposed to be one of two multiples. 0, 2, 4, 6, 8. Okay? And it is supposed to be divisible by 3. It means when you add the digits to each other, they are what? One of three multiples. So 2 plus 4, it's gonna be 6. What about choosing 3? 4 plus 2 is 6 plus 3 is 9, and 9 is one of the three multiples, and it is even, so absolutely it is divisible by 6. Great. What about this? What about 0, right? Makes sense. I'm gonna leave this for you. And divisible by 3, of course, the sum of the digits is supposed to be one of the three multiples, so 7 plus 1 is 8, plus 1, you will have 9 in total, so yes. What about here? 2 plus 5 is 7. So 7 plus a number, you get one of three multiples, so what about 2? So now you have in total 2 plus 2 plus 5, it is 9. And what else I want to complete with you? I'm gonna just cover these two questions and this four, of course. So just here we need to circle the names of the 3D shapes, simple 3D shapes with each other. They made this compound shape, okay, which is represented in each picture. So here, as you see, you have this and you have this. But before anything else, I want to remind you about some important shapes here, as you see, guys. Bismillah. First, as you see here, we're talking about something which is called prism. What do you mean by prism, teacher? It's a shape, it's a 3D shape, okay? It has two bases. This is a base, for example, and back there's another base there. Here we have a base, and back you have another base. So you have two parallel bases, okay? They're parallel to each other, okay? They are two bases. And you have what? You have side faces, which are what? As you see here, I have, for example, three, one back and one under it. Here I have a lot of side faces, as you see, one here and one down here. For example, I have one base and another base, two bases and other side faces, as you see, one base here and one base here, and we have side faces that are matching both bases with each other. And the most important thing, that these side faces are rectangles, are all rectangles. As you see here, you have a base, they have the same shape, and you have also side faces, they are all rectangles. So this is the prism, okay? And according to the base's shape, we said what is the type of prism. For example, the base here is a triangle, so we say triangular prism. The bases here are squares, so square prism. The bases here are rectangles, so rectangular prism. Here we have the bases are pentagons, so pentagonal prism. So here we have hexagon. Both bases are hexagons, so hexagonal prism, and here octagon, so octagonal prism, as you see. And something else that, look here, the square prism and rectangular prism, they have a name, which is cuboid. Both they are called what? Cuboid. It's hard a little bit to write, but I'm gonna write it to make sure that you'll not forget it, okay? It's a cuboid. What about the pyramids, teacher? Pyramids, it has only one base. This is the main difference between prism and pyramid. It has one base. For example, here we have base, and you have the side faces. And you have here you have one base, and here you have the side faces. And here you have one base. Sorry, wait. Yes, one base. It's not clear enough to you, but try to imagine. Here is the base. It's a rectangle, and all of the faces, as you see, they are triangles. It has four side faces, which are all triangles. What about here? This is the base, one base in pyramids, and the rest of the sides, the rest of the side faces are triangles. Here you have a base, and the rest of the side faces are also triangles. Here you have a base, and the rest of course, one base, and the rest of the side faces are triangles. Now, according to the base, you call the pyramid. For example, here triangular pyramid, or you can call it triangle-based pyramid, squared pyramid because the base is square. Here you have a rectangle, so rectangular pyramid. Here pentagonal pyramid or pentagon-based pyramid. It's okay. Here hexagonal pyramid because of the base, it is hexagon, and here octagon, so we call it what? Good job. Yes. Now we go back to call the shapes, to call the simple shapes which made this compound shape, which is represented in the picture. So here, what do you have? What do we call this? It's a prism. Two bases. Oh, sorry. Two bases. One here and one here. Two bases, and they are connected with each other by rectangle side faces. So it's a prism. What is the kind of prism? Look at the base. It's a square. So a square prism, or we say it cuboid. This is a cuboid, and also since this is a cuboid, also this one is a cuboid. So you have two cuboids, guys. There are represented in this picture without, with each other as a compound shape. What about this? What about this one? Or let's start with this one. What do we call it? Simply, it's a cuboid, right? It's a cube. And what about this? Look, it has two faces, two bases. This is a base, and back there is a base, and they are connected with each other by, well, by a rectangle. So it's gonna be a triangular prism because the bases are triangles. And what about this one? It has one base, and it's a square. So it's gonna be pyramid. They did not mention the type exactly related to the base, but it's okay. It's a square base pyramid. And what about this down? Yes, it's a rectangular prism, right? Or cuboid. Good job. Finally, the last question in this revision, find the missing digits. So just we want to apply the same steps of division to find the missing digits. So Bismillah. First of all, we look at question number A. We have 2, 8, and another digit divided by 4. So we have 280 something divided by 4. The answer or the quotient is something in the tens place and 1. And the remainder is 2. And something else. In the box, just you need to fill one digit. You have one missing digit, okay? In each box. And you need to find all of the missing digits in all of the boxes. This is why we have S here, but in each box we have one missing digit only, okay? So we start with 2. Can 2 be divided by 4? No, of course, it's less than 4, so we take 28. 28 divided by 4. We say the first step is to divide. Remember, we divide, we multiply, we subtract, and we bring down. Thank you. So, Bismillah. 28 divided by 4 is there a number? You multiply by 4. You get either 28 exactly, or if there's no number, so any number less than 28, close to 28, very close, and less than 28. Of course, we can get exactly 28 by multiplying 4 by 7. So now, 7. After division, we multiply. 7 times 4, it's going to be what? 24, and we knew this, 28, and we knew this before. What else? We let's subtract. 28, 8 minus 8 is going to be 0, 2 minus 2 is going to be 0 also. And now after subtract, let's bring down. So we will bring this unknown digit down here. I brought the box. I brought it down as it is. Hello? Okay, now this number divided by 4 is going to be 1. Give me a number. When you divide it by 4, you will get 1. 3? No, of course, it is less than 4. 2? No. 1? Of course, no. What about 4? Let's try 4. Yay. 4 divided by 4 is 1. Now, after division, we multiply. 1 times 4, it is 4. And let's subtract. 4 minus 4 is going to be 0. Ooh, the remainder is 0. But look, the remainder is 2. Oh, no. It's not 4. Let's change the number. What about 5? Actually, 5. It has 1 4, yes. 5 divided by 4 is 1. But when you multiply 1 times 4, you will get 4. And 5 minus 4 is 1. So the remainder is 1. No. Let's change it. What about 6? I guess 6 is going to work, yes? Because 6 divided by 4 is 1, 1 times 4 is 4, and 6 minus 4 is going to be 2. Oh, yes, the remainder is 2. This is what made my question correct. So this box, it has 6. So the dividend is 286, and the quotient is 71, and the remainder is 2. Great. What about B? Let's think about B. Now, can a 3 be divided by 6? By 7? No, of course. So this number, 30 something, it's going to be... So 30 what? Divided by 7, you will have 5. Oh, is there a number you multiply it by 7, you get 30 something? Sorry, is there a number you get it when you multiply 7 by 5, you get 30 something? Yes, of course, 35. Cool. Because 35 divided by 7 is 5. We divided, now we multiply. 5 by 7 is 35. Cool. And then we subtract. Go ahead. 5 minus 5, 0. 3 minus 3, 0. And let's bring down. It's 9. Now 9 divided by 7, it is 1. 1 times 7, it is 7. 1 times 7 is 7. And now 9 minus 7 is 2. And of course 2 is less than 7, so yes, it is our remainder. Cool. Yes, here we go. And the last question, guys, we will divide 425 by a number, by a unknown divisor. We will get 80 something as a quotient, and the remainder is 0. Let's try. 4 divided by something equals 8. Makes sense? It doesn't make sense. Is there 4? Or is there a number you multiply by 8, you get 4? Absolutely not. Or you can say 4. How many specific number in it? And this number of times is 8 times. Got it, guys? Let me repeat it again. 4 divided by something equals 8. So one way is 8 times this number equals 4, or there is 8 times of this unknown number in 4. So it doesn't make sense. It's like saying, oh, I have 8, for example, 2's in 4, or 8 1's in 4. No. Or even 8 threes or any other number? No, of course. So let's take 42. 42 divided by a number equals 8. What do you think? Is that a number I multiply it by 8, I get 42? Actually, no. Okay, but let's look for a number close to 42 and less than it. What about 8 times 2? It's 16. 8 times 3, 24. No, 8 times. What about 8 times 7? 56. No, it's greater than 42. What about 8 times 6? 48. So 8 times 5, yeah, it's going to be 40. So let's try it. Let's put 5 here and see. 42 divided by 5 equals 8. Yes, 8 times 5 is 40. Let's check 5 times table. 5 times 8 is 40. This is the closest number to 42 and less than 42. So it is 8, correct. After division, we multiply 8 times 5, 40. Now 2 minus 0 is 2, 4 minus 4 is 0. And now let's bring the 5 down. And let's repeat, right? We divide again, we repeat. After bringing down, we should repeat if we have digits we did not use. So we brought the 5 down and we have 25. Let's divide again. 25 divided by 5, it is 5. 5 times 5, it is 25. Let's subtract 0, 0. Oops. 0 here also. We subtracted, right? And oh yes, the remainder as 0, correct. If you have any question, please don't hesitate